So this, I think, might be the 6th video for our chapter, Work with What You Got. Now, we are trying to understand climate, and a big part of climate is how the sun hits Earth. Our last video talked about this a little, but we're going to talk a little more to hopefully make sure this is clear of how sunlight hits Earth and decides climate. And we're also going to make sure we talk enough so you can answer these questions, because we haven't done that yet either. All right, first off, it's important to know that the way that the sunlight hits the surface decides how intense the light is, and it determines how warm or cool the climate is. So we experience the highest temperatures, the warmest climate, where sunlight hits the sky perfectly perpendicular. So where it hits most directly. Let's look at this simulation. It says the most direct light hits at the equator. This is perpendicular. When the light hits the surface perfectly, so when the sun goes over our heads, completely 90 degrees above our head, the sunlight is most strong and the climate is most warm. So basically perpendicular. These two lines, right? Consider if line 2 were the surface of Earth, if line 1 is going through it and hitting it perfectly perpendicular, it's going to be more intense climate. Just like you see most direct here. And least direct, do you see how it hits at an angle? This is not perpendicular. Light does not hit the surface here perpendicular because the Earth is curved, and when light hits the more curved parts of Earth, it's not as strong, not as intense. In fact, let's watch this. So this is over the year. So watch these months change, and you can see that the areas that get the most direct sunlight differ. This is our summer. Look, the more direct light is closer to us on Earth during the summer months, and watch this light. Watch that we get less direct light during the winter months. You can see it's at a higher angle, right? Less perpendicular. This is why climate changes each year depending on the season. So perpendicular, when light hits the surface perfectly perpendicular, like this, light hits the surface of Earth. If line 2 is the surface of Earth, line 1 hits the surface really directly. It's kind of like getting a perfectly executed jab to the face right here. This is perpendicular. The fist comes and hits it perfectly at a 90-degree angle to the face. The fist is one line. The surface of the face is line 2, right? Just like light comes in, boom, hits it very direct, and it's perpendicular. So it's most intense. And then here you can see the punch hits at an angle. It doesn't land perfectly perpendicular. Just like here. Light hits the angle here, but it's spread out for one thing, so it's not too focused. So when light hits the curved areas, it spreads out more and it's less intense. So relate this intensity of sunlight and heat at the equator. So if the equator gets direct light, would we say that it is a direct hit, or would we say it's low angle at the equator? And then look at the North and South Pole. Number 2, you would say North and South Poles equal, and is it low angle or a direct hit at the North and South Pole? Answer that now, please. So make sure in your notebook you write slide 32, and then answer the 2 questions, 1 and 2 for slide 32. For each area, you just decide low angle or direct hit, okay? So for the equator, direct or low angle, and for the North and South Pole, direct or low angle, the way the light hits it. All right, moving on to slide 33. 33, we don't have any definitions, but we do have 3 questions we want to answer. So in your notebook, please write 33 or slide 33, and let's begin answering questions. So the reason why certain parts of Earth are always warmer than others is partly when you get a direct hit, let's say at the equator, you see this yellow line? It's small here compared to these. So when light doesn't get spread out as much over an area, when it's more direct, light is more focused over a small amount of area. But in these higher pole areas, do you see the size of the yellow line there? It's bigger because light spreads out because it hits at a lower angle. This is perpendicular hit. This is lower angle hit. So as it spreads over a larger area, it doesn't heat it as intensely. It's the same idea with this light. As light's spread out, it's less intense. But when you get a direct hit on the surface, So it's spread out now. Now it's more intense. There you go. And it starts the fire. All right, so if you haven't yet, write slide 33 in your notebook, and let's answer question 1, 2, and 3. It says number 1, it says, what latitude would you expect a desert? So which latitude here do you think gets hit by the sun most directly, most intensely? North Poles, South Pole, which would be 90 degrees north or 90 degrees south, or do you think it's 0 degrees where the equator is? Which area has light spreading out the least, where it's most direct, and it has only a narrow area really focused where it's most intense? What do you think? Then put that latitude here for number 1. So you would say 90, 60, 30, or 0. Number 2, it says, why would you expect a cold biome at 60 degrees north? So what's happening to light at 60 degrees north here that would cause the climate to be colder? Describe using the ideas we've talked about. All right, so again, why would you expect a cold biome at 60 degrees north? Well, you could say cooler blank. Are we talking about weather or climate? Be clear. What have we been studying? So you could fill it in. You could say cooler blank because blank, what are we talking about hitting the surface? What is this coming from the sun to here, right? So write what you need to right here about what's hitting their surface. And at 60 degrees north, are you getting more or less of that? And so is it hitting more or less directly, and is it more or less focused and intense? Choose more or less as you think you should for both to complete the sentence. So feel free to copy the sentence and fill in the blanks or choose the correct answers to have your response. And then finally it says hypothesize the latitude of a rainforest. So which areas are getting hit most directly with light, right? Here you go right here. Let me restart this. So it shows you what areas of Earth are getting hit most directly and most focused and intensely with light. So based on where you're getting the most direct hit, which latitude would that be? So you can use this, and you can also come back to this here. What part of Earth is getting hit most directly, where the light is spread over a small area that's strong and focused? That's where you would expect a rainforest, because a rainforest is hot. So what latitude do you think? Good luck. All right, on slide 34, we have a new idea. It's called Climax Community, and it's what you call an area in nature that has very little change. So the climate doesn't change. If it's warm, it stays warm. If it's cold, it stays cold. And it gets similar amounts of rain, or it always is dry, but it just doesn't change. The climate stays the same, plus the species there stays the same. Let's copy this definition for slide 34. So pause it if you need to. And then let's move on to slide 35. We have a new definition. So I want us to get the definition for biomes. We used the word biomes earlier. We used the word biomes in our definition for climate. And we used the words biome when we were describing latitude. So we said biomes are found only at specific latitudes. So we're talking about it with climate because biomes have specific rain, wind, sunlight, and temperatures. And we also find biomes at certain latitudes. Remember these degree lines. So we finally, on slide 35, have the official definition for biomes. It is a large group of ecosystems, an area in nature, that share the same type of climax organisms. It also shares the same type of stable environment or climate. So it's an area on Earth that has a stable environment, climate, with little change or succession, and it also has a specific type of organisms. So it has a specific group of species that are always there. That's a biome. We're going to be studying these Earth biomes. We got rainforest, temperate rainforest, tropical rainforest. We have desert, grassland, deciduous forests, what's called boreal forest, tundra. We're going to study these, 1, 2, 3, 4, 5, 6, 7. We're going to study these 7 biomes in a special activity coming up. We'll be doing it in class. All right, remember, in your notebook, write slide 35 and copy down this definition for biomes. All right, slide 36 will be important for us in class because it's going to be instructions on how to do our biome activity. It's going to be a student work activity, so in class, you will be learning in using good scientific skills to try to identify what parts of Earth have which biomes out of the 7 we just mentioned. And you're going to make arguments too. And this is like a little snapshot of what the picture looks like of the worksheet. We'll be doing that in class. And I probably have a special video also to help teach you if you missed this day, so don't panic. Here's a copy of the worksheet plus a little bit of work examples to help you on what region B or C might be, maybe desert, maybe grassland, maybe taiga. You get temperature and precipitation, information on the climate, and then you will use your evidence of precipitation and temperature, you'll use your climate evidence to predict what biome it is. And then down here, you'll just use argumentation. So you're going to use evidence to support your hypothesis or the biome you think it is. And you'll do that for regions D through F2. So there'll be 6 total regions. You're going to predict what biomes there are based on the climate of precipitation and temperature. All right, on slide 35, when we first introduced what a biome was, we said it was a large group of ecosystems. But what are ecosystems? So let's look officially at what ecosystems are, and let's practice a little more vocab so we can better understand what a biome is, okay? We can better understand how big biomes are also. So we're going to cruise on over to slide 42, and check this out. We have 1, 2, 3, 4, 5 different levels of organization in nature when we study ecology. The smallest one is the organism. So a single individual of a species, and then if you have a bunch of them together, you have a population. And if you have a bunch of different species of populations, you have a community. So it's a collection of a bunch of different species populations. And then if you have the community, so a bunch of different living species populations living in an environment and using their surroundings and the abiotic variables, you have yourself an ecosystem. So an ecosystem is an interaction of the communities, a bunch of different organisms that are all having big populations, and how they use their environment or their abiotic factors and environment. Finally, if you take a bunch of ecosystems and group them together, because they have similar climates, you have biomes. So biomes are a collection of ecosystems of similar climate and species, or similar climate and ecosystems, which is species and abiotic variables. In your notebook, please write slide 42, and let's get the definition for each of these. Pause now in order to write the definition for each of these, please, from organism, population, ecosystem, biomes, and community. So pause it and get all these down. And then in your notebook, what I'd like you to do is do this. It says arrange each of these from smallest to largest. So organism is the smallest, and biomes is the biggest. So you would say, for slide 42, you would say organism smallest, and then what would be the next one until you reach biomes, which is the biggest level of organization. Good luck. Here's slide 43. We'll work on this activity in class. We'll have fun with it. We'll draw some pictures to represent the different levels of the organization, but here also to help you. So if you're confused by question 2 and how to arrange them in the right order, you can look at the picture. An organism is a single person, so this is a human, one human. Then you have a population of a bunch of humans. And then a community is humans plus another species. We have cat species, dog species, and human species. That's a community, a bunch of different species of organisms. And then the ecosystem is different living things, plants and animals, using abiotic things like sun and water. That's the ecosystem. If you have huge ecosystems grouped together, they take over large areas of the world and biomes, and they all have similar climate and similar species. All right, folks. Now we're on to our final problem. We're introducing a new problem now that we know what biomes are, now that we've studied them. In your notebook, you would introduce a new problem and you would decorate it so it looks fabulous. The new problem is, will the biomes of the world need protection due to climate change? So we are going to be studying the hell activity. We're going to be going to hell, doing that activity, and we're going to be trying to learn more about this problem. So it's our new problem. So in class, we'll be doing this hell activity. Remember, hell. And we'll be doing this activity in class to learn if climate change is a real threat. Make sure you write slide 44 and copy down this new problem and decorate it with some colors to show